Welcome back. Let's practice using the distributive property to simplify variable expressions. Alright, so here's our first two examples. In both cases, we want to simplify the variable expressions, and both of them are going to involve the use of a distributive property. So let's start with the first one here. We have 4 times the quantity 5x minus 2. Alright, now you know you need to use the distributive property because you have a number or a term being multiplied by a quantity or a set of parentheses that contains multiple terms inside of it. Alright, and so what the distributive property allows us to do is simplify an expression like this by taking that term on the outside and multiplying it by all of the terms inside the parentheses. Alright, so in this case, to simplify 4 multiplied by 5x minus 2, we will multiply 4 by 5x, and then we will multiply 4 by negative 2. So that would look like this. This would be equal to 4 times 5x, and then you want to move on to the next term, so you'll have plus 4 times negative 2. So I'll write down 4 times the negative 2. Alright, and so now we have used the distributive property. Now all that's left to do is to further simplify this variable expression by actually performing the multiplication between 4 and these two terms. Alright, so first up we have 4 times 5x. To simplify that, you want to multiply 4 by the coefficient of that variable term, and 4 times 5 is 20, so this is equal to 20, but then you want to keep that same variable part of x, so it's 20x. And then you want to add that to 4 times negative 2, which we know is negative 8. So we have 20x minus 8. That right there is our variable expression simplified using the distributive property. All right, now let's move on to this example over here. It looks a little bit different, but we can still use a distributive property. You'll notice that we have the quantity of 3a plus 1 multiplied by 9. All right, it doesn't matter that we have a term to the right of the parentheses as opposed to being on the left. The distributive property can still be used. We will multiply 9 by both of these terms inside the parentheses. All right, we'll multiply 9 by 3a, and then we'll multiply 9 by 1. So that will look like this. We will have 9 times 3a, and we will add that to 9 times 1. Okay, and so simplifying, we want to multiply 9 by the coefficient of this variable term. So we have 9 times 3, which is 27. So this is equal to 27 times that variable part of a. You want to keep the same variable part. And then we have plus 9 times 1, which is 9. And so 27a plus 9 is the simplification of this variable expression using the distributive property. Okay, let's take a look at some more examples. Next up, we have these two. Let's start with this one over here. We have the negative quantity of y squared plus 6. All right, or another way that you could view this is that we have negative 1 multiplied by that quantity of y squared plus 6. All right, so that's really what's going on here. The number on the outside of the parentheses is negative 1. And so using the distributive property, we would multiply negative 1 by both terms in the quantity. And so that would look like this. We'd have negative 1 times y squared, and then negative 1 times 6. And so writing that out, we have negative 1 times y squared, and then plus negative 1 times 6. And so simplifying, the coefficient of y squared is just 1. So you're going to multiply negative 1 by 1, which is negative 1. So this would be equal to negative 1 y squared, but we don't typically write a coefficient of negative 1. So we'll just write that like this. We'll have negative y squared. All right, and then we add that to negative 1 times 6, which is negative 6. So really, I'll get rid of this plus sign, and we'll just write minus 6. Okay, that is the simplified form of this variable expression. Now, something to note for future problems where you just have a negative sign in front of a quantity, the way that you can distribute this negative faster is to just simply change the sign of each term inside the parentheses. All right, so instead of writing out negative 1 multiplied by both terms, you could go directly from here to here by just changing the sign of these two terms. Make y squared negative y squared, and make positive 6 negative 6, and you have successfully distributed that negative through the quantity. Okay, so in the future, that's what you can do to make this process a little bit quicker. But then moving on to this example, we have 2 times the quantity 10x squared plus 6x minus 15. And so this looks a little bit different than the examples we've done so far because the parentheses have 3 terms inside of them. But that doesn't matter. The distributive property still applies here. It's just that we have to multiply this number on the outside, in this case 2, by more than just 2 terms. We will multiply it by all 3 of them. Alright, so we'll multiply 2 by 10x squared, then we'll multiply it by 6x, and then we'll multiply it by negative 15. So here's how we will simplify this variable expression. We have 2 times 10x squared plus 2 times 6x plus 2 times negative 15. Okay, so we just multiplied 2 by each of those terms. Now simplifying further, we want to multiply 2 by each of those terms using our properties of multiplication. Starting with the first one here, the coefficient of the variable term is 10, so you want to multiply that by 2. 2 times 10 is 20, and so then if we keep the same variable part of x squared, we get 20x squared. And then 2 times 6x, you want to multiply 2 by 6, which is 12, and keep that same variable part. So we have plus 12x, and then you have 2 times negative 15. That's equal to negative 30, so we have minus 30. And so that right there is the simplified form of this variable expression using the distributive property. Now, as you start working with more terms in your variable expression, like we had here, you do want to be on the lookout for any like terms, right? To fully simplify a variable expression, you want to combine any terms that have the same variable part. That does not happen here. All of these terms in our answer have different variable parts. We have x squared and x, and then negative 30 is just a constant. So there's nothing else that we can do here to simplify this, but do be on the lookout for potential like terms when you do these problems of simplifying variable expressions using the distributive property. Next up, we want to simplify this variable expression. We have 5 times a minus b minus 4 times a plus b. All right, so in this example, we have 2 instances where we need to use the distributive property. We have 5 being multiplied by these 2 terms, and negative 4 being multiplied by these 2 terms. Or another way that you could think about it is that you are subtracting 4 multiplied by both of these 2 terms. So just for the sake of doing something a little bit different, I am going to write it out that way, and I'll show you what I mean in just a second. But it is important to realize that we are going to use the distributive property here twice. We're going to multiply 5 by a, and then we'll multiply 5 by negative b, and then I'm going to multiply 4 by a, and then multiply it by b. And we're going to subtract both of those terms. All right, so here's what this is going to look like. This will be equal to 5 times a, and by the way, notice that the coefficient of each variable part here is just 1 or negative 1, so you can multiply that 5 right into that coefficient, and so 5 times a would result in 5a. There's really no need to write 5 times a like this. We know that that's going to be equal to 5a, so I'm just going to skip right to it. In the same way, 5 times negative b will give you negative 5b, and then we're going to subtract multiplying 4 by a and by b. And so you want to keep those in parentheses because we are going to be subtracting both of those terms, right? So you'd have 4a and then multiply 4 by b, so you'll have plus 4b, and then you want to close out the parentheses. Okay, so we multiplied 4 by both of those values, but we did not include the negative sign, so it still stays outside of those 2 terms, and so now we can take care of that negative by doing the distributive property again. But remember back to what I said in an earlier example, if you have a negative sign in front of a set of parentheses, distributing that negative is as simple as just changing the sign of each term inside the parentheses. So really what we have here is 5a minus 5b minus 4a minus 4b. Okay, and now you might be tempted to box this in, but look at what we have here. We have 4 terms, and some of them are like terms, right? 5a and negative 4a both have the same variable part of a, and then negative 5b and negative 4b have the same variable part of b. So we can combine those like terms to further simplify this variable expression. All right, so once again, we have 5a and negative 4a, and negative 5b with negative 4b. Okay, so if we combine our like terms, you want to add the coefficients of 5 and negative 4, which gives you 1. So we just have a for when you combine those two terms. But then for negative 5b and negative 4b, negative 5 plus negative 4 is negative 9. So we have minus 9b. You keep that same variable part. And now there are no more like terms, which means that this right here is the simplified form of this variable expression with the help of the distributive property and combining like terms. Okay, and by the way, you did not have to do this distribution the way that I did it. If you prefer to multiply negative 4 right away to both of those terms to get right to negative 4a and negative 4b, feel free to do that. But there will be some circumstances in more complicated variable expressions where you may prefer to keep that negative separated and not distribute it through a quantity. So I just wanted to show you that that is something that you can do as well. You can distribute the number without the negative. Just remember to keep the parentheses around the two terms that you multiply that value by. Okay, but let's take a look at another example. Here we want to simplify this variable expression, 9 minus 3 times the quantity 4y plus 6. Okay, so this time we only have one instance where we need to use the distributive property. And so let's do that here. We're going to be multiplying negative 3 by both of these terms. At least that's how I'm going to do it this time. You could do what I did in the previous example, which is keep the negative separate and multiply 3 by both terms, keep them in parentheses, and then distribute the negative. I'm going to do it the other way this time. I'm going to do it the way I did not do in the last example. So I am going to distribute negative 3 to 4y and negative 3 to 6. All right, I'm going to multiply it by both of those terms. So what we will have here is 9. That's not going to change. We still have 9 plus negative 3 times 4y. So we have negative 3 multiplied by 4y. And then that will be added to negative 3 times 6. So we have negative 3 times 6. Okay, now simplifying further, we still have 9. But then negative 3 times 4y, you want to multiply negative 3 by the coefficient of 4. So negative 3 times 4 is negative 12. And then you want to keep that variable part of y. So we have minus 12y. And then we have plus negative 3 times 6, which is negative 18. So we have minus 18. But now we're not quite done yet. We do have some like terms. Specifically, we have two constants that can be combined. 9 and negative 18. You could add together to be negative 9. So our final answer here would be negative 12y minus 9. That is the simplified form of this variable expression. Hey there, real quick, before we take a look at the next example, if you find my tutorial videos here at JK Math to be helpful, then I'd like to invite you to join my membership site, JK Math Plus, where you get access to many perks, including bonus content and my exclusive community. The bonus content includes dark mode versions of my videos, extra example problems, and more, while the community is a private space online where you can post questions, have discussions, and study together with me and other members. To learn how to join and see a full list of everything you get access to as a member, you can head over to jkmathematics.com/plus. I'll have a link for that in the description of this video. So if you are interested in becoming a member, feel free to check that out. It's a great way to support me and the tutorials I make, as well as a great way for you to learn math better. But for now, let's take a look at the next example. For our next example, we want to simplify this variable expression. We have negative 2 times the quantity x squared plus 5x minus 3, and then we are subtracting the quantity negative 3x squared minus 7x plus 6. Or you could think of it as negative 1 multiplied by that quantity. All right, so we have two instances here where we need to use the distributive property. We want to distribute negative 2 through this quantity, and then we want to distribute negative 1, or distribute this negative through this quantity. Now that's going to be a lot simpler. Remember that when you distribute a negative or distribute negative 1, you just want to change the sign of each term inside those parentheses. So when we get to that, that will be pretty smooth. But before we get there, we want to do this distribution first. We're going to multiply negative 2 by x squared, then negative 2 by 5x, and negative 2 by negative 3. All right, so this will be equal to negative 2 times x squared plus negative 2 times 5x plus negative 2 times negative 3. And now let's distribute that negative through this quantity. We're just going to change the sign of each term. So negative 3x squared will become positive 3x squared. Negative 7x will become positive 7x. And positive 6 will become negative 6. Okay? Now, let's do this multiplication over here. Negative 2 times x squared. You're just multiplying negative 2 by a coefficient of 1. So that simplifies nicely to negative 2x squared. Then, negative 2 times 5x. You want to multiply negative 2 by 5, which gives you negative 10. But then you want to keep that same variable part. So we have minus 10x. And then negative 2 times negative 3 is positive 6. So we have plus 6. And then you just want to write down the rest of these terms. So we have plus 3x squared plus 7x minus 6. Now, you want to look to see if there are any like terms that we can combine. First thing I see is that we have a negative 2x squared and a positive 3x squared. Those are like terms that we can combine. Also, I see we have a negative 10x and a positive 7x. They have the same variable part of x, so we can combine those like terms as well. And then finally, we have positive 6 and negative 6. Well, those are just two constants that add together to be 0, right? 6 minus 6 is 0. So we don't even need to combine those. They just cancel each other out. There will be no constant in our final answer here when we simplify this variable expression. All right, so to finalize our answer, we want to add our like terms that we identified that will not result in 0. Negative 2x squared and 3x squared, adding the coefficients gives you positive 1. So we would just represent that with x squared. The coefficient is assumed to be 1 in that case. And then for negative 10x and 7x, negative 10 plus 7 is negative 3. So we have minus 3x. Okay? And that right there is the fully simplified form of this variable expression. It's pretty nice if you think about it. We started out with all of these different terms, and they were being multiplied by different numbers, and it all simplifies down to just two terms, x squared minus 3x. That's pretty nice. All right, now let's take a look at one more example for this video. All right, so here's our last example. We want to simplify this variable expression, which is by far the most complicated expression that we have looked at in this video. This is really going to test your skills of using the distributive property. Notice that there's more than one set of parentheses here. We have 4 times the quantity y plus 4 times another quantity of x plus y minus 2. And then after all of that, we are subtracting 14x. All right, so it's important to notice that that 14x that we are subtracting is not inside any parentheses, so this 4 does not get multiplied by that negative 14x. Okay, so don't multiply 4 by that term. You only want to multiply 4 by anything that is inside these parentheses. And really, you have a couple different options here. If you wanted to, you could distribute this 4 right now. You could multiply it by y and multiply it by this entire quantity right here. 4 times this quantity. You would have 4 times 4, which is 16. You could do that and then distribute that 16 through this quantity, or you could wait and distribute this 4 through this quantity right now. And that's what I'm going to choose to do here. I'm going to start by simplifying what is inside these parentheses, and then I will multiply 4 by what's left. Okay, so what I'm going to do is distribute 4 through this quantity. So we'll have 4 times x, then 4 times y, and then 4 times negative 2. All right, so rewriting this expression, we still have 4 times y plus 4 times this quantity. So now we will use a distributive property. We have 4 times x, the coefficient of x there is just 1, and 4 times 1 is 4. So that just turns out to be 4x, and then 4 times y will give you 4y. So we have 4y, and then we have plus 4 times the negative 2. All right, so I'll write down 4 times negative 2, and all of that is in the parentheses, and then we're still subtracting 14x. Okay, now my next step here is going to be to simplify as much as possible inside these parentheses before I distribute this 4. You don't technically have to do that. You could distribute 4 right now and then do any simplification by combining like terms, but I'm going to choose to simplify within these parentheses before we use the distributive property again. All right, because notice that we have like terms of y and 4y. We can combine those, add the coefficients. 1 and 4 would be equal to 5. So you could rewrite this to be 4 times 5y, and then you still have that 4x, and don't forget about 4 times -2, which would be -8. So we have -8, and then you're still subtracting 14x, but it's not inside those parentheses, okay? It's still on the outside. So we simplified what's in the parentheses to get this expression, which can't be simplified any further, but we can now use a distributive property. We want to multiply 4 by each of these terms inside the parentheses. Okay, so we're going to multiply 4 by 5y, then we'll multiply 4 by 4x, and then multiply 4 by -8. Okay, so if we do that here, we'll have 4 times 5y plus 4 times 4x, and then plus 4 times -8. And then don't forget that we still have this minus 14x at the end there. So we'll write minus 14x. Okay, now I'm going to continue my work up here. I'll write the next line right there. We need to do some multiplication. 4 times 5 is 20, so this results in 20y. You want to keep that same variable part. So we have 20y, and then plus 4 times 4x. 4 times 4 is 16, so you'll have plus 16x, and then plus 4 times -8, which is -32. So we have minus 32, and then once again we have minus 14x on the end. So minus 14x. Okay, so now we're almost done. You just want to check to see if you have any like terms that you need to combine. And if you look at our terms here, there are 2 that are like terms, specifically 16x and -14x. They have the same variable part of x, so we can combine their coefficients. 16 minus 14, or 16 plus a -14, is positive 2. So this is equal to 20y plus 2x minus 32. And that's our final answer. That is our variable expression, fully simplified after using the distributive property and combining like terms. Okay, and if you want to test it out, you could try doing it the other way. Remember at the beginning I said that you could multiply 4 by y and this quantity, so you'd have 16 times x plus y minus 2. You could try that. If you do all of the simplification, you should end up with the same answer that I got right here. And so hopefully that demonstrates that there is a little bit of leeway in how you go about simplifying variable expressions. But just remember that when you do your distributing, to multiply the term outside the parentheses by each term inside. Okay, but with that, this was the last example for this video. However, I do have another on my membership site, so if that's something that interests you, feel free to look into becoming a member. You can find all the details on my website at jkmathematics.com/plus. I'll also have a link for that in the description of this video. If you have any questions, please let me know in the comments, but if you don't have any questions, this is all I had for now, so I will see you next time.